In this video, you will learn to identify parts of a circle and to know and use the relationship between radius and diameter. So here in the following slide, we see a circle, and we have different parts of a circle, different segments and points. So our first definition is actually going to be the word circle. So I think at this point you know what a circle looks like, but our definition of a circle is it's a closed curve in which every point is equidistant, or the same distance, from a fixed point called the center within the curve. So what does that mean? Well, we have a closed curve, so we see the circle is a closed curve. It's not a straight line, it's a curve, and it's closed, there's no gaps in it. And any point on the curve is the same distance from the center. So if we pick this point right here, for example, and we measure the distance to the center, that distance will be the same as if we picked this point over here and measured the distance to the center. It doesn't matter what point we pick on the circle, it's going to be the same distance from the center point. So here, this would be a circle for that reason. Now, we can name a circle, and we name a circle with the center point. So because the center of the circle is point O, that's the middle point, we can call this circle O. And notice your circle symbol, all right, is basically a circle with a dot in the middle. And that's your circle symbol. So circle O is what we can call it. If the center point were center point A, it would be circle A. So the symbol for circle is basically a circle with a dot in it. All right, and the center, as we've already mentioned, is that point O. It is the point right in the middle of the circle. The next term we have is radius. So radius is the segment connecting the center to any point on the circle. So for example, if we were to look at the segment going from point O all the way over here to point R, that segment OR, so segment OR, that is a radius. And it's a radius because it fits the definition. It is any segment going from the center point to another point on the circle. Another radius in this picture would be the segment from point O over here to point L. So that segment OL is also a radius. It's connecting the center to another point on the circle. So OL and OR both would be radii of the circle. And by the way, radius is singular, so that's the singular word. That means one segment. The plural of that word is radii. So it's R-A-D and then two I's at the end. So that's the plural. So OR and OL are radii of the circle. All right, so make sure you know both words. Typically use the word radius, but radii also be aware of as well. The next term we have is a chord. So notice the spelling of the word chord has the letter H in it, C-H-O-R-D. And what this is it's a line segment where both endpoints are on the circle. So for example, we see here this segment from S to R, both endpoints are on the circle. So segment SR would be a chord. There's actually another chord in this picture, and that would be the segment going from point R all the way across over here to point L. So that segment from R to L is also a chord because it is connecting two points where the endpoints are on the circle. So SR and RL both would be chords of this circle. Now RL is a special kind of chord because it goes through the center. So if a chord that goes through the center, the word we give to that is diameter. So diameter, by definition, is a chord that goes through the center of the circle. And as we said, segment RL would fit that description. Now over here with this picture, we want to point out another term, and the term is a central angle. So the definition is basically in the name itself. A central angle is an angle where the vertex is at the center. So it's an angle at the center. So there's actually two different angles that would fit that description. Well, three technically, but so here, see point O. If you create this angle right here, angle DOC, where the vertex is here at the center, that angle is a central angle, angle DOC. Now another one would be starting here. If we go AOC, so this angle right in here, O is the vertex and it's the center, that would also be another central angle because it's an angle with the vertex at the center. So angle COA. Alright, so those would be two different angles. We could actually do the straight angle. So the straight angle would be the one straight across. So angle DOA. This angle here is 180 degrees. Okay, it's a straight line. So that would be a straight angle. That would technically be a central angle as well. Angle DOA. And by the way, a circle has 360 degrees total. Right? If you can imagine here, the straight line, this angle is 180 degrees, as we mentioned. So that's the one side, but if you think about this other side over here, there's also this other side with 180 degrees up here. So if you put that together, that gives you a total of 360 degrees. All right, so a circle has 360 degrees in it. And you might have heard that used before, where if, let's say somebody jumps and spins around one complete time. Let's say you have somebody standing and they jump in the air, turn, and land right back the same way that they were originally standing. So if they do one complete rotation in the air, that's called a 360 because they turn all the way around 360 degrees. They went in one complete circle, one complete rotation. So a circle has 360 degrees total. Now to finish off, we want to talk a little bit more in detail about the radius and diameter, because there's a relationship between the radius and diameter. So remember, the radius is halfway across the circle. It's going from the center point to a point on the circle. All right, so if you put two radii together, if you put OA and OD together, okay, so if you put those together, that gives you the diameter. So if you put two radii together, two radius together, that's going to form one diameter. So for example, if AO, that length were, let's say, 6 inches, okay, the other radius is going to be the same length based off your definition of a radius. So the diameter all the way across would be twice that. It's going to be 12 inches total. All right, so all the way across is 12 inches. So the radius is going to be half the diameter, or in other words, the diameter is twice the radius. So let's try an example here. Let's say we said that the length of OD is 5. It could be 5 inches, 5 feet. The question is to find the length of AD. So see if you can do that. What is the length of AD? Well, from O to D, that's the radius. If that is 5 inches, or 5 whatever, then the length from A to D all the way across is twice that, right? Because AO would also be 5. So all the way across from A to D, all the way across, that length is going to be 5 times 2, which is 10. So if OD is 5, then AD, the length of the diameter, is going to be 10. Here's another example. What if we said the length of AD is 18, and we're trying to find the length of OC? How would you do that one? Well, if AD is 18, that is the diameter. That's all the way across, right, from A to D. If that's 18, the diameter is 18, the radius is half of the diameter. The radius is going to be 9. So that means AO would be 9, and OD would be 9. right? 9 times 2, or 9 plus 9 is 18, which is the length all the way across. But the question is asking to find the length of OC. Well, OC is another radius, right? From the center to this point over here, it's going to be the same length as all these other radii. The distance from any point on the circle to the center is going to be the same within that circle. So OC would also need to be 9. So again, it could be 9 inches, 9 feet, whatever, but the length is 9. Now, one thing to point out, by the way, we didn't really explain it yet, but here, the notation, okay, where it says OD or AD, okay, so it's referring to the length of the segment. So for example, if you had a segment OD, so if you have a segment symbol above it, that's just talking about the shape. So it's just referring to that shape. All right. Now, without the symbol above it, if you just have OD like that, that is asking to find the length of segment OD. So when you don't put the symbol above it, that indicates that we're finding the length. It's a number. It's a measurement. All right. So if the symbol is above it, we're just talking about the name of the shape, the name of the segment. But if there's no symbol above it, we specifically are asking to find the length of that segment. All right. So when it says find AD right here, that is asking to find the length of AD, the length from point A to point D. All right. So make sure that you know the difference. Make sure you understand that notation. And that concludes our lesson for today. We will see you next time.